Imagine looking up at the night sky and seeing a planet with rings so vast they dwarf Saturn's. This isn't science fiction. It's a reality in a distant star system. We're talking about a planet, or perhaps a brown dwarf, known as J1407b. Its ring system is absolutely colossal, stretching hundreds of times wider than the beautiful rings we admire around Saturn. Let's journey about 434 light-years away to the constellation Centaurus to uncover the secrets of this super Saturn. J1407b was discovered in 2012 through a project called the Super WASP, Wide Angle Search for Planets Survey. This survey uses a method called transit photometry to find exoplanets. Scientists observe distant stars, looking for tiny periodic dips in their brightness. These dips often signal that a planet is passing in front of its star from our point of view, an event we call a transit. In 2007, the Star 1 SWASP J14074 394,542.6, which is quite similar to our Sun but much younger, showed a very unusual and complex series of dimming events. The light from the star flickered and dimmed for a staggering 56 days. This was not the clean, simple dip in light that a typical planet transit creates. The pattern was incredibly intricate, with deep, sharp dips and long periods of partial dimming. This complex light curve puzzled astronomers for years. A team led by Eric Mamiak at the University of Rochester finally proposed a groundbreaking explanation in 2012. The star was being eclipsed by a giant, multi-ringed system orbiting a companion object, J1407b. The sheer scale of this ring system is difficult to comprehend. If J1407b were to replace Saturn in our own solar system, its rings would dominate our night sky. They would appear many times larger than the full moon, stretching across the heavens as a brilliant, impossible structure. The night would never be truly dark. The rings are estimated to have a diameter of about 180 million kilometers, which is more than the distance from the Earth to the Sun. That's roughly 200 times the size of Saturn's main rings. The total mass of the dust and particles within these rings is thought to be equivalent to the mass of Earth. Imagine our entire planet, ground up into dust and ice and spread out into a magnificent celestial halo. Unlike Saturn's rings, which are mostly made of water ice, the composition of J1407b's rings is likely different. Given the system's youth, these rings are probably composed of denser dust and rocky material. This is the kind of stuff that eventually clumps together to form moons and planets, a process known as accretion. The light curve data from the 2007 transit revealed an incredibly detailed structure within the ring system. Scientists identified at least 37 distinct rings. The system is so dense that some parts block more than 95% of the star's light as they pass by. But what's truly fascinating are the gaps. Within this massive disk of material, there are large, clear gaps. One particularly significant gap is located at a distance of about 61 million kilometers from the center of J1407b. Scientists theorize that this gap could have been cleared out by a newly formed moon, an exomoon, orbiting J1407b. The gravitational pull of this moon would sweep its path clear of ring material. Estimates suggest this exomoon could be quite large, possibly up to the size of Earth or Mars. If confirmed, this would be one of the first discoveries of a moon orbiting a planet outside our solar system. The rings themselves tell the story of planetary formation in action. We might be witnessing a snapshot of a protoplanetary disk, the kind of disk that surrounded our own sun billions of years ago, and from which all the planets, including Earth, were born. The object at the center of this magnificent system, J1407b, is also a source of mystery. Its exact nature is still debated among scientists. Initial estimates placed its mass somewhere between 13 and 26 times that of Jupiter. This range puts it right on the blurry line that separates a massive gas giant planet from a brown dwarf. Brown dwarfs are often called failed stars. They are more massive than planets, but not massive enough to ignite the sustained nuclear fusion of hydrogen in their cores that would make them shine like a true star. Further analysis has suggested that J1407b might be even more massive, possibly up to 40 times the mass of Jupiter, which would place it more firmly in the brown dwarf category. Regardless of its classification, it's a behemoth. Its orbit around its parent star, J1407, is also highly unusual. It appears to be on a very long and eccentric, or oval-shaped path. The orbital period is estimated to be around a decade, but this is still an approximation. The eccentricity of the orbit means that J1407b swings in close to its star, and then far out into the colder reaches of its system. This dynamic orbit could have profound effects on the stability of its own ring system. The star's gravity would tug and pull at the rings, potentially disrupting them over long periods. This has led some researchers to suggest that the ring system must be a relatively young and transient phenomenon. Over millions of years, the material will either be ejected from the system, fall into J1407b, or, most excitingly, coalesce to form a family of moons. So, are we certain that this is a ring system? The evidence from the 2007 Light curve is very strong, and the ring model fits the data incredibly well. However, science thrives on confirmation. Astronomers were eagerly awaiting the next predicted transit event, which was expected to happen between 2015 and 2018. Amateur and professional astronomers around the world monitored the star, J1407, hoping to catch a repeat of the spectacular 56-day eclipse. But the event never came. The predicted window passed without any significant dimming of the star. This non-detection has added another layer of mystery to the J1407b saga. There are several possible explanations. One is that the initial estimate of the orbital period was incorrect, and the next transit is simply yet to happen. Another, more complex idea is that the orbit of J1407b itself is being altered. Perhaps there is another large, undiscovered object in the system whose gravity is changing J1407b's path. A third possibility is that the ring system is not perfectly aligned with the orbit. It might be precessing or wobbling like a spinning top. If the rings were tilted differently during the predicted transit window, they might not have passed in front of the star from our viewpoint, meaning we would see no eclipse at all. Despite the missed transit, the 2007 data remains a powerful piece of evidence. The intricate pattern of dimming is difficult to explain with any other known astrophysical phenomenon. The J1407b system serves as an extraordinary natural laboratory. It allows us to study the processes of moon and planet formation in a way we simply cannot do within our own solar system, where that process was completed billions of years ago. It challenges our understanding of how planetary systems form and evolve. The sheer size of the ring system suggests that the conditions in the early life of a star system can be far more extreme and dynamic than previously thought. The existence of such a massive disk around a planetary mass object raises questions about its origin. Was it formed from the leftover material that created J1407b itself? Or was it captured from a catastrophic collision with another large body? Each possibility paints a dramatic picture of the chaotic early life of a solar system. The study of exoplanets like J1407b pushes the boundaries of our imagination and our scientific instruments. It reminds us that the universe is filled with wonders that often exceed our wildest speculations. From a single peculiar flicker of a distant star, scientists have pieced together the story of a world with rings of unimaginable scale, a potential nursery for new moons, and a system that continues to keep its deepest secrets. The quest to understand J1407b is ongoing. Future observations, perhaps with the James Webb Space Telescope, might be able to detect the faint thermal glow of the rings themselves, or provide more precise measurements of J1407b's mass and orbit. Until then, J1407b remains a tantalizing glimpse into the grandeur and diversity of worlds beyond our own. It's a true Lord of the Rings on a cosmic scale, a super Saturn that continues to inspire awe and curiosity. Thanks for watching, and be sure to subscribe to Space Repo for more journeys into the cosmos.